Now that we know what a differential equation is, let's look at different types of differential equations, different ways to organize them or classify them. The way we'll start is ordinary or partial. Do we have an ordinary differential equation or a partial differential equation? For the purposes of this class, I'm only going to really be looking at ordinary differential equations. My only reference to partial will be now whenever I explain the difference between the two. And in order to do this, we're going to start by considering two different equations. F of x equal to 3 sine x, which only depends on one variable, and f of xy equal to e to the x sine y, which is a two-variable equation. Well, we can take derivatives. On the left, we have that df dx is equal to 3 cosine x. And this would be an example of an ordinary derivative. For the equation on the right, I can take two different derivatives. I can take the derivative with respect to x or the derivative with respect to y. So the derivative with respect to x would be e to the x sine y. The derivative with respect to y is e to the x cosine y. And these are known as partial derivatives. So essentially, ordinary derivatives deal with functions that rely on a single variable. It's the kind of things that we learn in Calculus 1. Partial derivatives are going to be the derivatives of functions with multiple variables, which is more like what we're dealing with in Calc 3. So an ordinary differential equation, which we'll abbreviate with ODE, has ordinary derivatives, like dy dx is equal to 2y plus x. A partial differential equation, or PDE, is going to contain partial derivatives, like the derivative of f with respect to x minus the derivative of f with respect to y equal to 2xy. So that's the main difference, is does the differential equation contain ordinary derivatives or does it contain partial derivatives? The next way we'll look at classifying differential equations is their order. And the order is just determined by the highest order derivative. So we're looking at what's the largest derivative that we're taking. A first order differential equation would be something like dy dx equal to 7y plus 3, because our derivative is the first derivative. A second order would be like the second derivative of y with respect to x plus 8y equal to e to the x, since my highest derivative is the second derivative. A third order differential equation would be like the third derivative of y minus 2 times the first derivative equal to 5xy, since my largest derivative is the third derivative. And you can keep going. You can have higher orders as well. The next thing we'll look at is the difference between dependent and independent variables. And to do this, we're going to start by looking at it for a normal function, and then we'll go over to the differential equation. So let's consider the function y of t equal to 3 e to the t. The y of t tells us that y depends on the variable t. So that's what this means. That's what this function means, is that y depends on t. So we say y is the dependent variable and t is the independent variable. The idea being that you pick a value for t and it determines y. Y depends on the value you pick for t. So now let's look at differential equations. So this time I have dy dt is equal to 3y. The dependent variable is what you take the derivative of. In this case, y. We're taking the derivative of y. The independent variable, on the other hand, is what you take the derivative with respect to. In this case, t, since we took the derivative of y with respect to t. So with differential equations, essentially the one on the top of the derivative is your dependent, the one on the bottom is your independent.